Hello, hello. So that's working? Okay, I guess we can start. Welcome to the second day of Scala.io. It's great to be back after half a year. So it's great to have actually two Scala.io conferences in a year. So my name is Adam Warski. I come from Warsaw, Poland. I work at Software Mill, which is a company doing quite a lot of stuff with Scala, but not only. I'm personally also maintaining some Scala open source projects as part of my job. Maybe you have heard about direct style. Maybe you have seen some code snippets. They look pretty and they look like simple, clean, and so on. But you know, it's you may start wondering if we are doing direct style. Are we still doing functional programming, right? Or maybe to do functional programming, we should use functional effect systems such as Zayo or Cas-Effect or Kayo. So we will try to answer that question. We will try to answer if direct style is functional, and if it's not a binary choice, how functional is it, right? Okay. Let's actually start with what is functional programming. This will be like the longer part of the talk. It's not an easy question, I guess. I've been doing functional programming since my university days. I started with OCaml and Scheme. And I only answered this question now, so you know, it took me a while. But yeah, we won't consider the merits of functional programming. That's like a separate topic for a separate long presentation. So we will just focus on what actually functional programming might be. So first we will take a practical take. You know it when you see it. So we will look at some code snippets and try to extract some traits of code that might tell us that a given style or a given approach is actually functional as opposed to, I don't know, imperative or procedural and so on. Okay, so let's start. So that's actually JavaScript, just so that it's you don't have too much Scala in the morning. So we have the same functionality on the left and on the right? So which one of those is functional, you would say? Yeah, well, it's your left, right? So this one looks much more functional than the right one, right? And why is it? Well, first of all, we have some function applications over here, right? So we have the map, filter, reduce. These are all functions that we call on the collection. This is compared to for loops and ifs on the right-hand side, right? We also have some higher order functions over here, right? So I guess like the first two traits, maybe they are quite obvious. And the first two traits of functional programming is that we are using function application a lot. We are using higher order functions. And in the non-functional section, we would have like explicit control flow structures like for and ifs. Okay, so these are like the basic traits. So let's continue with another example. So this is Scala now. We are back to our comfortable land. So, you know, these two, they both look quite functional, right? We have filters over here and we have filter over here. But which one would you say is more functional? Yeah, the one on the right. And that is because here we are using a function as a value. We are representing a function as a value, right? So we are saying that the dietary restriction is a value which is a function. And thanks to that, we don't have to repeat this filtering logic over here, right? Just because we can represent functions as ordinary first-class values, right? So a function is a value just as a string, as a number, and so on and so on. So yeah, so another trait of functional programming is that we can express functions first-class values, and also another thing over here is we have an if, which is an expression, right? That's also a trait of functional programming languages, that most things are expressions. Maybe not all, but most of them are. And in imperative or procedural languages, many things will be, we have this distinction between expressions and statements. Okay, so we have some more traits. Let's carry on. So now it gets a bit more complicated. Well, here we have Scala, here we have Java, so the answer is simple, right? So that's functional, that's not. But why? Okay, so Over here, well, the functionality again is the same. We've got Chris. We've got a mapping from persons to addresses where they live. And now Chris turns 30 from being 29. And when he turns 30, he moves to Krakow from Warsaw. I don't know why, but people sometimes do that. So over here, we are using immutable data structures. And over here, we are using mutable data, right? So I would say that the immutable approach is much more characteristic to a functional programming language than the mutable one, right? Well, in both examples, we are using functions, right? For example, the setAge function, the setAge over here is a function, right? We call it with some parameters. The put over here, which mutates the friends map, is also can be considered a function. However, these functions, they don't return anything meaningful, right? They usually return unit or maybe a Boolean over here. But we call them only for their side effects. This is compared to the functions like removed, like copy, like updated, which actually return updated data structures, right? So here we have functions which actually return meaningful results. So immutable data would be a trait of a functional programming language, mutable data of a non-functional language. Okay, and finally, like we had some sign of effects, right? We had mutable data. So now let's look at effects in a more general way, right? So which of those would you say is most functional? We have 3 now. No, it's not that easy, right? Okay, so well, here we have some Java code, right? And when you read all 3 snippets, you think about them in exactly the same way, right? You know, you have a rocket, right? To launch a rocket, we all know that we need some fuel, we need some navigation, then we do some checks, we ignite the engine, and then we tell the world about our success, right? So in all 3 cases, we think about the code in the same imperative way as a sequence of steps. But the technical representation of these steps is different in each case, right? So here we have the Java version, and when we call these methods, these effects are immediately executed, right? So these are side-effecting methods which actually do something. You know, they interact with the outside world, they interact with the rocket systems, whatever. So here we have immediate effects, right? Here we have a Haskell version, which, when you actually call these functions, they don't do anything. They just return a description of the side effect, right? So each of those returns an IO, and the do notation over here actually sequences a number of those IOs into one big description of a side-effecting computation, which, when eventually run, will produce those side effects. So this is like a lazily evaluated version where we represent effects as values. And the last snippet over here is kind of a middle ground. That's like Unison code. We have the I/O ability over here, which is lazily evaluated, which is denoted with the apostrophe. So this is like middle ground, right? You can take an imperative perspective on that code, but you can also say, because we have these abilities, these computations are suspended, so they are lazily evaluated as well. So usually we would say that, like, the Haskell version, of course, is most functional because it's Haskell, right? Because we represent effects as values. And generally, representing things as values is a very functional thing to do. And we would say that this is imperative because we have immediate effects. But we think about the code in a very similar way. Okay, and finally, the last snippet. So once again, the same logic. But here we have, a version where we have an order, we parse the order, the parsing might fail, it might throw an exception, validating an order might fail. Then, you know, if we have a loyal customer, we apply some discounts, then we calculate the taxes, the total, and we return the invoice. However, you might notice that all of these methods have to mutate data to actually perform the calculations, right? So here we have a version which uses mutable data. And now here, we have a more functional approach. And why is it more functional? Well, the parse order, it probably returns something like an either, right? Then we flat map with validate, which also might return an either. So we represent the error effect as a value. So once again, we represent concepts as values. Then we map over it, and we actually calculate, we create the invoice and we calculate all the discounts as a series of function applications and function composition. So another basic trait of functional programming is that we actually use function composition a lot as compared to imperative steps which mutate some data. Hope everybody's okay. Oh, and finally, before we proceed to the theoretical section, there's also, I think, a distinction. Well, very often, functional programming and object-oriented, they can live together, as witnessed by Scala, I guess, and F# probably. But sometimes they do provide different answers to the same questions. And I think one such question is what to do with behavior and data, right? So in object-oriented programming, we often combine behavior and data, right? We try to encapsulate the data within our classes and to hide it from the user. While in functional programming, we do the opposite, right? We have data structures on which functions operate. But the data is not hidden inside an object, right? The encapsulation often means that we need to do mutation to actually change and to operate on the data. The functional approach, as we said, is often more focused on immutability. Okay, so that's like a summary of what we talked about so far. So the functional approach would use high-order functions, function composition, functions as first-class values, immutable data effects as values, and the imperative or the non-functional styles, doesn't have to be imperative, would do like the opposite. Okay, so that was like a practical, a practical take. So what does the theory tell us about functional programming? So, of course, the first thing we would do is go to Wikipedia, where we can read that functional programming is a paradigm where programs are constructed by applying and composing functions, which is more or less what we have already discovered through our practical examples. It was like our first example was about applying and composing functions. And, it's not written here explicitly, but it's kind of in the spirit of what this says over here, that this needs to be the primary tool of constructing programs. And if it's to be the primary tool of constructing programs, well, we probably would need to have functions as first-class values to actually work with this conveniently, right? Also, as a result of this approach of using application and composition of functions as our primary tool, we get a more declarative style of programming, right? We usually are able to express our logic without explicit control flow, without explicit force, loops, and so on, and so on. The simple definition already has some consequences, which we have seen is rooted in practice as well. But the definition has one weak point, right? So you can say, like, what is a function? Okay? So if you actually follow the link to the function in the definition of functional programming on Wikipedia, you can see that the definition says that it's a callable unit of software, it has a well-defined interface and behavior, and it can be invoked multiple times. So, I guess it's a reasonable definition. But, of course, for the more mathematically inclined, we all know that a function is a mapping between two sets, right, which assigns for each element in the domain, assigns a unique value in the value set. It's deterministic, it's idempotent, it's effect-free, so the output depends only on the input. So that's like the mathematical definition, right? So these two definitions, they are not really exactly the same, right? Most importantly, this one allows side effects in a function, and this doesn't. So now, depending which definition of a function we take, we get two flavors of functional programming. So I will call this casual functional programming, okay? And of course, the other one will be pure functional programming. So that's a name probably you have seen. That's a name you haven't yet seen, but maybe it will get used more after this presentation, we'll see. Yeah, so we got those two flavors of functional programming, and both are valid, but it's worth distinguishing what do you actually mean by saying a function. And you could say that in the casual variant, if we just FP is about using functional application and composition, where a function is just a callable unit of software. It's just using small methods, and small methods is exactly what clean code advocates. So maybe casual functional programming is just clean code, right? And to a certain degree, yes. I think clean code has a lot of functional programming elements in it, but it's just the first step, right? So if we have some spaghetti code, and then we refactor it to use small methods, we do use a lot of functional composition and functional application in our code, and that's fine, but then it's only one, it ticks only one of the checkboxes in our functional programming list, right? Then we can take the plunge and use higher order function, we can higher order functions, we can use immutable data and ADTs, algebraic data types, we can use a language which is expression oriented, and so on. We can represent things as values, and when we do that, we proceed to casual functional programming, and then when we actually represent, when we represent all effects as values, we proceed to pure functional programming. So it's like it's a spectrum where you can move from spaghetti code to pure functional programming, if you wish. And I would argue that a lot of value of functional programming lies in this first step, in moving towards the casual variant. Okay? So once again, same functionality, but written in 3 different styles. So yeah, we have a list of people IDs. We want to fetch them from the database, which is a side effecting function. It goes to the database. Then for each fetched person, so here we fetch them. Then for each fetched person, we want to send a request, like probably does an HTTP request. And then we just want to extract something from the response, right? So this imperative version over here, it's hard to read. Now it's hard to understand what it's doing, right? But then we can refactor it to a functional style, right? We can use higher order functions over here. We can use function application. And it's already much better, right? We don't do pure function programming because these are side effecting. But the difference between this and this is huge, okay? And we already gained a lot in the way in our expressivity, comparing to like this, let's say, spaghetti version. So here we have the spaghetti, here we have the casual functional programming, and then, of course, we can move even further by representing effects as values, which we do over here, right? We use traverse, which probably is a sign that we actually use pure functional programming. So this returns an IO, this returns an IO. So we have some nested maps over here. The functionality is the same. We also gain some things which we gain by using a purely functional effect system, but I think the gains are smaller than taking the first step. Okay, so there's some other definitions circulating on the web on functional programming. I won't spend too much time here because we also need to get to direct style. Stack Overflow, there's, of course, a question was functional programming. One of the answers also mentions this distinction between casual and pure functional programming. There's also one definition that I particularly write on Reddit, which says that a functional language is one in which it would be hard and impossible to do ordinary, easy things if you didn't use functions as first-class objects, which I think underlines an important aspect, that the language itself should, it's not only that it's possible to represent things as first-class values, it should be ergonomic to do so, right? It should be easy, it should be programmer-friendly, okay? So in many languages, you probably can do that, but whether it's practical is another thing. For example, it's very easy and very programmer-friendly to do in Scala. In other languages, not always so. And finally, we can take a look at the Haskell definition. So not much new here. The Haskell definition focuses on having expressions which can be evaluated and it says that if we change global state, if we have mutable state, if we have statements, not expressions, we are actually doing, we aren't doing functional programming. So it's more like of a negative definition. Let's say what you shouldn't do. Okay, so summing up, what is functional programming? Okay, so I would say that there's no single answer. There's like a list of characteristics, I think, that you can check whether your language supports it, whether your approach supports some of these traits, and whether it's actually ergonomic to use it in your language, right? So we have, of course, applying and composing functions as the primary tool to construct programs. We have functions as first-class values. But then we have also other traits which might tell us if we're actually doing functional programming or not, right? So I wouldn't say that you necessarily have to represent effects as values. It's definitely a plus, but it's not a must, okay? And that would be the distinction between the casual and the pure variants. Okay, so now we know more or less, or maybe now we know less what's functional programming, but let's say we know more or less what functional programming is. What is direct style then, right? If we are to judge if direct style is functional, what is it? So there's no Wikipedia entry yet, so no help there. You can go and start one if you would like to be famous on Wikipedia. So we'll use other authorities. So the other authority we are going to use here is Martin. So Martin gave a presentation, it was last year? Yeah, last year's Scala about direct style. You can go on YouTube and watch it. And there he defines direct style. And he says, it's not on the slide, but he says that direct style is the opposite of continuation passing style and a control monad. So we will unpack what it means in a second. By the way, if you don't know about Scala, I think I have a discount code. So Scala is the perfect distance from Scala I/O if you would like to come, because it's like almost half a year into the future. So right between Scala I/O editions. So yeah, I hope to see you there. It's a Scala conference that we run in Warsaw. Okay, back to direct style. Then the other authority that we might actually ask is ChatGPT, right? Because AI is going to replace us anyway, so we might just ask it. So ChatGPT actually gives more like a behavioral definition of what direct style does. It's kind of similar to what Martin says, but maybe in like lower level technical terms. So here's, again, the opposition of direct style to continuation passing style, right? So in direct style, you would have sequential execution where each expression has to evaluate completely and give us the result before proceeding to the next step. It's often blocking, right? Well, readable flow, of course, that's questionable, but hopefully so. So ChatGPT actually has a clue. So how would we define that direct style? I would say that direct style is an approach where the results of any effectful computations are available directly, right? That's where the directness lies, right? So they're not wrapped in a future, in a promise, in an I/O. So that would be the control monads that Martin is talking about. So by default, of course, it's still possible to use them, but the default mode of operation would be that if we have anything effectful, it's actually available directly. And we try to avoid continuations, right, either as callbacks or as monadic wrappers. But you say, we actually need continuations for performance, right? We used to program in this direct style long ago, but then it turned out that having a thread per request actually doesn't scale that much, right? We wanted to have like 100 requests per second on our server, and we only have 100 threads, and these requests take a while, so how do we do that? So that's how people invented continuation passing style, that's how they invented futures, then they improved futures to introduce IOs and so on. But now, actually, different languages try to hide continuations from us and still give us a nice user-friendly programming language in various ways. So we have a couple of approaches. Kotlin's coroutines, I think, is one of the older ones, right? In Kotlin's coroutines, they translate, the compiler translates the code that you write using, suspend functions. So you need to color them. You still need to have a marker that the function might suspend the current coroutine, and it's compiled into a finite state machine. So that's built into the compiler. So the end user syntax is quite friendly. We've got Java's virtual threads, which actually embed a runtime which allows you to multiplex a lot of virtual threads to run on a small pool of platform threads. Unison abilities also do something similar. It's to Kotlin, I guess, most similar to Kotlin. They compile down their code into a continuation passing style. So these continuations are there in Java, in Kotlin, in Unison, in OCaml probably as well. They are there. They're just hidden from you. You'll never see them. Some people would actually like to get access to them, but for example, Java doesn't want to give us that possibility. So the continuations are there. They're just not visible to the end user, to the end programmer. So in effect, you can get some nice syntax. So that's OCaml, for example, right? We can get some nice direct syntax where we just call a series of functions or a series of methods which actually have some side effects, and their results are available directly. This here is Unison, which also, I think that's an example with, putting something in storage and raising exceptions. So we get this nice direct syntax. The continuations are there, they're just not available directly. You may know Alex, he's the author of Monix, and he often asks those good questions, let's say, on Twitter. Actually, this one prompted kind of this talk, so I'm very happy he does that. And he was asking if direct style, well, he wasn't asking, he was more like stating that direct style is in fact imperative programming. And we all know that imperative is bad. We should do functional, right? First of all, they are not exactly opposites, but let's say they are. But I wouldn't say, I'm not sure if I would convince Alex, but I would like to present an argument at least. And I would say that these two concepts are kind of orthogonal. You can do programming with monads in a purely functional style, but you can also do continuation passing style, so indirect style, using an imperative way, like futures, right, which are side effecting. So you can have indirect style, which is both purely functional and completely non-functional, right? And probably similar with direct style. You probably can't do pure functional programming in direct style, but you can still do a lot of functional programming with direct style, because direct style only says how we represent effects, and that we don't use monads, for example, to represent effects. It doesn't say anything about all the other characteristics that we've talked about. So the imperativeness, you have a lot of imperativeness in functional languages as well, right? The Haskell example over here, it's a sequence of steps that's very imperative. It's embedded in a functional language, but it's it's an imperative sequence of steps. Some people actually understand imperative as like doing global state, doing statements, and so on and so on. And once again, this does using direct style doesn't necessitate you to use mutable state, for example. So direct style consequences. If we are doing direct style programming, we are probably using the language's built-in control flow constructs, so we don't have to use special versions of loops or ifs that are available for monads. We have direct execution, so we don't need the intermediate library level runtime like in Scala effect or IO that's often embedded inside the VM or inside the language, and the effects are direct, they're not represented as values, which this last point here is kind of non-functional, right? But the others are fine. So that's just summing up what's direct style. That's how we defined it, just so that we can keep it for further reference. Okay, so how functional then is direct style? Let's try to quantify it a bit. So I would say direct style is as functional as possible, but without introducing I/O. Okay, so that's the last step that we don't want to do, because it would mean that we actually don't represent effectful computations directly. And this also probably means that we cannot do purely functional programming with direct style, right? There are some limited direct style options out there. So we've got that's Katz effect with async await, right? That's Zio with Zio direct, which allow you to do direct style in a limited way. It's limited because you cannot use high order functions, for example, freely. You cannot, embed those .run or those .await calls anywhere. There's a limited number of places where you can use them. So a limited direct style is possible with the pure FP. But if we want to do direct style, pure functional programming probably is not going to be possible. So we have to live with that. But let's actually try to answer the question, how functional is it? And to do that, we will do a very subjective scoring of various approaches. It's totally invented by me. You might have a totally different score. But let's see how it goes. Okay, so first let's see how Scala plus Katz effect would score, or plus Zio, like Scala plus a purely functional effect system would score. So first of all, we have a category that's like provided by the language, right? We have functions as first-class values. That's, of course, possible in Scala. We have an expression-oriented language. Most things in Scala are expressions, not all of them, but most of them are. And we have a functional standard library that's also, I think, important when considering the functionality of an approach. Whether the standard library works with you or works against you. Okay? So these are like high scores. Then we have, the other traits of functional programming that we have identified, right? Applying and composing functions, well, that's mostly the primary way you write code when using Katz effect or Zio. You mostly use immutable data. You probably don't do shared mutable state, and you probably represent effects as values. However, all of these are only based on discipline, right? It's not checked by the compiler. It's not mandated in any way, right? You probably do a lot of log.info in your, or maybe you don't, but many people do. Log.info in your purely functional code, and it's completely fine. The compiler won't say anything. Finally, we have a small category whether the behavior and data are actually separate. Scala is a hybrid language, so we actually can hide. You can actually combine these if you want to. Okay, so now let's take a look at the direct style version. So these first three are unchanged because that's just how Scala works. Now what about the rest? Okay, so we still, in direct style, we still mostly work by applying and composing functions to a bit smaller degree because effects are no longer represented as values. So if we want to operate on effects, we just use semicolons. If we want to sequence effects, we don't combine them into a description or anything like that. So the score is a bit lower. However, we mostly use immutable data structures as well. Right? That's just the way you do things in Scala. It's actually harder to do mutable data, I guess. We use a lot of algebraic data types, so case classes, sealed traits. We avoid shared mutable state just because it's good practice. This is also, of course, based on discipline, so the scores are a bit lower. We don't represent effects as values. Well, maybe we represent errors as ithers, so there's like 2 points for that, at least. Okay. But let's try to put it in a perspective as to how it compares to other approaches. Okay. One note about pure functional programming and about this category of no shared mutable state, right? It's a very good practice to avoid, and it's great to actually avoid shared mutable state and not to make life harder than it is, but we will never actually escape it completely if we do pure functional programming or not. And that's because we have things like databases, HTTP, and so on. So, if we have those two threads, the first thread writes to the database, increases the age of a user. The second thread reads from the database. It's like a race. Like you don't know what they will actually do. So however we represent those two functions, if they return IOs, if they use abilities, if they use capabilities, if they use immediate effects, as a programmer you still have to think about the interaction more or less in the same way, right? The immutable shared state is there. It's maybe not as a global variable, because that would be just making life harder, but it is there, okay? But back to our functionality scorecard, we will take a look at Java, just to see how it compares to direct style, okay? So, you know, Java is a language. You can represent functions as first-class values since some time ago. Most things are statements in Java, not expressions, so a lower score here. The standard library is completely non-functional, mutable data structures, so no help there. So here the scores are quite low. What about actually working with Java? You know, of course, you can use immutable data structures if you really want to, but the Java ecosystem doesn't, mostly, at least yet. You know, you have records, you can do ADTs, but most of what exists in Java is actually mutable. So you will probably end up using mutable data structures anyway. Same with shared mutable state. We don't really represent effects as values, so the end score is quite low. So, you know, they try to introduce some functional things, like they call it data-oriented programming, which is functional programming just called differently. It's using ADTs mostly and separating data and behavior, but it's not really used widely in Java. And I don't think it ever will, like there's just too much Java history. So let's look at Kotlin, right? Kotlin is something in between Java and Scala. So it's much more expression-oriented. The standard library is slightly functional, let's say. For the collections, which are like the primary tool that we use every day, the collections are mutable. You often get read-only views of collections, but they are mutable inside. So, you know, it's like 2 out of 5, let's say. We work with immutable data and ADTs more often. We still don't use effects as values, right? So you can see that the score is somewhere in between Java and Scala. Also, let's look at Haskell, right? It should be our golden standard when it comes to functional programming. And indeed it is. It like has top scores everywhere, except for, you know, you can still cheat. There's actually no language out there which allows you to do purely functional programming end-to-end, right? Well, it allows you, but which mandates purely functional end-to-end. It might also be telling. You can always do unsafe perform I/O in Haskell, somewhere deep in your function. Nobody will notice, maybe. So it's also not the top score, but close. And finally, let's take a look at another contender. Rust, I think, is surprisingly functional for at least, you know, this metric might be completely broken, of course, or maybe Rust is a bit functional. But let's look at how it scores in our categories, right? Functions have as first-class values. It's there in the language. Most things are expressions. The standard library, you often work with mutable data because it's Rust, but it's quite functional in its flavor. Like we've got the higher order functions for working with collections and so on. So it's quite functional. We often work, well, we don't work with immutable data. We work with mutable data, but we do work with ADTs, right? We've got enums, we've got structs. So that's a concept that we know quite well. And we often use functions to actually operate on these data structures. So that's quite functional. We don't have shared mutable state because that's like the main feature of Rust, that you can't have shared mutable state. Of course, you can do unsafe still. There's an escape hatch, and we don't represent effects as values. So summing those up, you know, we have our functionality score over here. So unsurprisingly, Java is on the low side. Haskell is on the high side over here. So the purely functional Scala approach is quite high, quite close to Haskell. But the direct style in our functionality scorecard isn't that far away, followed by Rust and Kotlin somewhere in between. Okay, so, you know, that hopefully tries to answer the question how functional is direct style. And you can say that it's pretty functional. So it's, as I said, it's probably as functional as you can get. without introducing I/O, without introducing pure functional programming. So in a way, Scala is functional by construction, right? If we are using Scala, we have all those traits of a functional programming language. We have functions as first-class values, higher-order functions, it's expression-oriented, we have immutable data types. We just have to try not to spoil it. That's when we, try to advocate some approach as to how we should do programming in Scala. So we've got all those great tools, we just have try not to break it. And hopefully that's what we are doing in direct style. My interest in that evolved into a library. So you could say, that I'm trying to convince you that direct style is functional because I'm writing OCs, but it's actually the other way around. I'm writing OCs because I think direct style is quite functional, and because I think you can get a lot of value from functional programming just by using direct style, right? So in the OCs flavor, it provides some tools which aim to make it easier to actually work with direct style, like advocating using eithers for errors and exceptions for panics. So that's something similar to what you do in Rust. Of course, not using shared mutable state. That's twice. So we don't use shared mutable state. If you do need to, communicate some data between threads, you should use channels or flows, function composition, a prime tool for writing code. When you consider how much functional programming should you do, it's always a question at which point a given approach, be it functional programming, be it object-oriented, doing very orthodox object-oriented probably isn't wise as well, right? So at which point does FP actually start providing the diminishing returns, right? If you can go purely functional, if your team loves it, that's great, you will get a lot of benefits. If not, there's still a lot that you can actually gain. In the casual variant, I think, still provides a lot of value. And functional programming in Scala is, by Scala's construction, is both ergonomic and practical, and it's supported by the language, by the standard library, and the community also works towards it. And you might also know Runar. He's the author of Functional Programming in Scala book. And there's like an interesting tweet from him. They're often interesting. They're often not so easy to digest and understand. But what he says is that he doesn't anymore, I guess, care about purity per se. What he's more interested in how compositional an approach is, right? So what this exactly means is a topic of another presentation, so maybe you can try to uncover that at some point. But there's also something to think about, I guess, how compositional our approaches are. Okay, so just before the end, I would like to mention my company, who is sponsoring a lot of Scala open source projects, such as Tapir, STTP, OCs, and others, and Magnolia, although we will have to fix Magnolia, as Mateusz pointed out yesterday. So what we do is we try to help our clients with various technical problems mostly. So clients come to us when they need some more capacity or specific expertise in the areas where we work. So like Scala, Java, Kotlin, Rust, TypeScript, so mostly type-safe languages, but also we do a lot of work with Kafka, with Java migrations, optimizing cloud costs, and so on. So if you would be interested in that, come talk to me. And that's all I had. I'm here for the rest of the day, so if you would like to discuss, what functional programming really is, I'd be happy to do that, or what direct style is. So I guess that's all I had, and thank you very much. I guess I'm right on time, so I'm not sure if we are doing some questions. Yeah, okay. So if you would have some questions, I can try answering.
Hi, thanks for the talk. So my question is regarding OCs and specifically, how do you do inter-thread communication there? And especially, can you avoid mutability when communicating between threads?
Okay, well, no, you can't avoid mutability, of course, because the channel that is like the low-level primitive is immutable. It's like a queue with extra capabilities. So it's mutable, but it's a thread-safe, mutable concurrent data structure, yes. So that's one mutable thing that you need to use, actually. We try to kind of hide it, maybe, with a higher-level API. So there's like a flow API, which is lazily evaluated. And it uses channels underneath, but sometimes you do need to get to a lower level and actually use the immutable data structure.
Another question. What's your take on the effect tracking? So we don't necessarily need to wrap in direct style, but what's your take on seeing the effects in signatures one way or another?
Yeah, okay. So we actually tried that in Ox to track effects. We tried to have an I/O marker, which would tell you in the signature that this method might actually do some I/O. So it sounds like a good idea, right? To have signatures that don't lie, and to be able to predict if this method is going to take longer or shorter, or to know what kind of failure modes a specific method might have. But in practice, it turned out to be a burden, and you just had to put the I/O everywhere anyway. So in the end, we removed it. I'm not 100% sure if it's a good decision. However, I think the lesson here is that just having a marker trait which doesn't do anything, right? It was there only on the compilation, during compilation time. It never really did anything at runtime. It wasn't needed at runtime. It's usually just not worth it. If it's like a byproduct of actually having some runtime characteristic, then okay, great. But just for the sake of tracking effects, it turns out in practice it's more of a burden than benefit. And usually, if you have even the naming of the method kind of reveals if there might be side effects or not. So that's often duplicating information in that way.
One last question? No?
Nice talk, thank you. I'm curious, when writing applications, have you noticed any issues with a lack of referential transparency in functions? Has the side effects caused issues that were sort of unforeseen?
Okay, so referential transparency is something I left out on purpose because actually I have issues with it. It's not that easy to define. I know the common definition that you can replace expressions with values, right? But then, you have to ask yourself, what's a value? Because what is actually a value is like a value lives in a different world than the syntactical text of the program that you have, right? So if you actually go into program semantics, like the notational semantics, operational semantics, you often get that the value of a program includes the return value plus any side effects that it contains. So the definition itself of referential transparency is not that easy. But yeah, I kind of get the spirit of what it means, but I think it's more like a consequence of pure function programming. It's not like a benefit per se. I don't think you really often use referential transparency in your code. People often say that you can represent things as values, right? You can have a value which is represents a computation, and I would say in Scala you have vals and defs. You can just use a def if you want to have to have a computation, right? So to represent computations, we should simply use defs. That's the Scala answer, I guess.
Thank you.
Thank you very much.
Okay, great. Thank you. So have a good conference.